Guillermo Varela from Magni Europe, and I'm today here with Parametric Solutions. I'm with Sofia Malsten and Henrik Frank, and they are going to show us how Parametric Solutions works and how they are working to improve the built environment by utilizing generative design and artificial intelligence. With Rhino geometry engine and grasshopper scripting language as its core, they have created a web-based platform that lets architects and property developers create and explore different design possibilities directly in the browser. Remember that in the last 15 minutes of this webinar, we will have some time to answer your questions, so you can ask them in the chat during the webinar or at the end, and we will check them after the presentation. And also, I would like to mention that the webinar is being recorded and will be available on our YouTube channel probably tomorrow or at the end of this week. Thanks, Sophia and Henrik, for accepting our invitation. And please start with the presentation if you're ready.
Yeah, okay, perfect. So, yeah, I'll just start by sharing my screen. So, yeah, can you see the screen now?
Yeah.
Okay, perfect.
Working.
Yeah, so thank you very much for the introduction. My name is Sofia, and I have with me Henrik Frank today. And yeah, we're going to talk a little bit about generative design, Rhino Compute, and the cloud-based platform that we are building. So yeah, we are Parametric Solutions. We are a startup based in Sweden. And we are a team of architects, we're data scientists, and we also work with software engineering. And yeah, we work in different constellations. So myself, I am one of the co-founders. And then we have some consultants and some interns, and yeah, a wide range of different constellations. But in this webinar today, the speakers are me, Sofia, and also Frank. So will you introduce?
Yes. Yes, I'm Henrik, and I work with Sofia as a backend developer.
Yeah. All right. And yeah, a little bit of the agenda for today. We are going to present the background, where we are at the moment, what we've been doing so far. Of course, we're also going to dig deeper into a live demo of our platform. We will also share some experience and lessons learned when it comes to our development journey. And later on in the presentation, Frank will also cover some technical aspects when it comes to Rhino Compute and how we use the compute server. And then in the end, we will talk about what's next. And yeah, we will end the presentation with a Q&A in the end. But yeah, as mentioned before, like if you have any questions, feel free to ask them in the chat. Especially if you have any technical questions, Frank will try to answer them in the chat. And if it's not technical questions, then we will cover them in the end after the presentation in the Q&A. So a bit of a background, why we are here, why we have this webinar, what our mission is. So the background is that we are, as mentioned before, a team of architects. And we've been part of design teams several times, and especially in early stages, a lot of things are really unclear. There's a lot of parameters that you need to collect and that you need to understand to create buildings, and there are so many unknown parameters. So in early stages, you always have to think about connections, sightlines, context, noise situation. But you also have to think about customer insights, economical factors, demographics, and later on you need to think about installations, connections, shape factor, energy, and so on. And this list of aspects is really, really long. And yeah, you have to consider a lot of different aspects. So being an architect and being part of design teams in early stages can be summed up in one word, which is complexity. So our mission and what we would like to solve and contribute to is to reduce this complexity. And the way we're doing that and our approach is to write algorithms that iterates over a wide design scope. So we represent buildings as data structures and extract information when it comes to the building, and we build up like a data tree of different hierarchies so we can evaluate aspects for different design configurations. So when everything is quite unclear in early stages and we're facing a problem, we write algorithms, and we're later on going to go more into generative AI to actually produce a variety of different options and increase the creativity by producing variants and increase the creativity in correlation and in combination with the user. Later on in the process, we then want to support our users to actually make decisions based on that and make choices. So we want them to narrow down the design scope and support our users in finding a good solution in the end. And yeah, the approach that we're using is generative design. And I know that some of you are already familiar with the concept. But the way we approach it is that we, in a very schematic way, this is approximately how we work with it. So we have inputs to the left, where we have different types of inputs. So we have, first of all, we call it typologies. And that's if you want to do like what kind of massing you would like to place on this site. If it is lamella structures, if it is quarter structures, and so on. And then we have choices and preferences, and that is mainly like user inputs. So what are the dimensions? How many units do you want? What is your target FAR ratio? And density for the sites and other kind of both zoning regulations, but also other kind of economical factors and quality inputs. And then, of course, in the end, we have geographical context data. And that is for the site, we need to understand the context to be able to create design proposals that align good with what we have in the surroundings. These different types of inputs goes into our algorithms that starts to generate, and instead of like producing one design option, we produce a variety of different options by iterating over different input configurations. And we then measure KPIs and data and present that to the user to make it easier for the user to make a decision and continue with the design option based on data. So, I mean, the technology itself, that's nothing new. You can achieve similar things if you work in Grasshopper. You can work with parametric design, but you can also work with generative design and like genetic algorithms and optimization. But what we're trying to do is to make this accessible for people. So we built a cloud-based platform as a wrapper for this. And of course, as mentioned before, everything is based on Rhino Compute, and we're using Rhino Compute as an enabler for doing this. So the whole platform can be summed up in 3 different stages. We have the base data, which is the prerequisites for the site. We then have the design options, where we use generative design to support iterations and to produce a variety of different options. And in the end, we have also the analysis engine that we are working on at the moment, so that we also should be able to check the performance and validate the results generated in the design stage. So these are the 3 steps that we're working on. And the whole idea is to like shorter the lead times, especially in early stages, to create better insights, to work with easier collaboration, but also, as mentioned in the beginning, we also want to increase the creativity by producing a variety of different options. So yeah, that was a bit of a background, and I think the next step here is to actually dig deeper into a live demo. But before we do that, I see we have a raising hand in the audience from Valentina. If there is something that you would like to ask or say before we continue with the live demo? Okay, maybe not. We can continue in that case. And I mean, if you have questions, you can, of course, write them in the chat. But yeah, let's have a look at the live demo. So as mentioned, we've built a cloud-based platform and things are based on Rhino Compute in the background. We will later on go into the technical aspects of how we've done that, but this is just to give you an understanding of where we are at the moment, how it works, and yeah, to share some development insights. So when I log in, I have access to my previous created projects in a list like this, but I'm going to show you how to create a new project. So we've divided the whole setup phase in 6 different steps, as you see up here. So we have name, site, then we have studies. I'll tell you in a while what that means, requirements, and that's pretty much it for initiating a project. So the first step is quite simple, and the next step here is to find a site. And yeah, we wanted to make this process as easy as possible. So we've connected parametric design, generative design, Rhino Compute stuff with open data and GIS services. And we want to connect these workflows to create like a smooth transition and to make it easy to use for early feasibility studies. So you can search for any location in the world. I'm going to show you actually a site in Vienna. But you can search for any location. And when we zoom into a certain level, we will see that the 3D buildings start to appear for the context. And this is based on Mapbox. So this is the absolute minimum amount of information. But of course, in certain cases, you have more information, and then you should be able to override the existing data with your more up-to-date data. But in the cases where you don't have data, this is the minimum level of information to get you started. But if we zoom out a little bit, we also append different data sets, and we're using WMS services for adding data sets to this map. So actually why I went to Vienna here is that Vienna was one of the first cities that we started with to create and add data sets from the city of Vienna. So when I look here, we can toggle on and off the data layers. So if we zoom out here, we will see that we've covered the Vienna region with data from the city of Vienna. So this is the strategical plan at this level. And then when we zoom in, we will see that the resolution of data is changing. So then we will change the data, and suddenly we will go into another data layer where we will get more information about zoning and other kind of information. And when we zoom in even more, we will see that it will appear new kind of information here. So let's see here, we can go to so if we zoom out again, we can go to this spot here where we don't have buildings. And yeah, I mean, imagine if you don't have any information at all, you can toggle things on and off, but you can then switch to satellite and still do some quite rough sketches. And if you have more information, you can also do it in a more traditional way, such as uploading PDFs or uploading, we're working on uploading DVD files and other kind of shape files and other information for your property regions and for your zoning data. But yeah, then you can at least start sketching and create a draft. I'm just going to do like this. And you will see your site, you will see your area and the length of all of the different edges. And of course, the context is also important for doing feasibility studies. So you can click on the surrounding buildings and include the nearby buildings in your calculations and your sum studies later on. For OpenStreetMap, the footprints are often quite okay, but the heights you might miss some data when it comes to the heights. So to solve that, we've actually made it possible to override, and you can check from Google Maps or Google Earth and say, this is not 3 meters, this is actually 20 meters, and you can override the data and build up your surrounding scene. You can add some other quality elements, such as if you want to split the site, keep a sight line, or if you want to add a zone where you cannot build, or you can add certain access points where you should be able to access the site, and so on. But this is so far quite generic, and so far we have done nothing with Rhino Compute, but here it actually starts to become interesting and become, here we will see a connection to Rhino Compute. So what we're doing here is that we build up what we call a design library or a design template library. So what you see here is basically a set of grasshopper scripts in the background. So I can then select, okay, I have my site. I've done that in a generic way with data from municipalities and other GIS services and so on. Then I can click on different design templates. So if I click on single family housing, for example, I can select what kind of single family housing I would like to populate the site with. If I want to do chain houses, pair houses, row houses, and villas, and I select my types like this. And so the templates are built up in the same way. So you first have your types up here, and then you have some other generic parameters down here. But if I go back and if I do, yeah, this is another one. We have industrial buildings as well. So we have warehouses, single-sided and double-sided logistic buildings. And then we also have the residential. But what we also do here is that we actually match scripts with certain users. So we customize this if a client if they have very specific ways of doing things. So we've done a lot of customization work for modular construction, for example. If I click on this one, we will see that it looks different. So when I log in, I have access to this one, and we can match users with certain design scripts. But I'm going to show you the generic one for the residential development. And yeah, first of all, the types again. And here we're going to select, I want to do quarters, and I want to do lamellas, and try out some point houses as well. And yeah, you can configure each and every type with dimensions and stories. And down here, you can do some generic inputs, such as the typical floor height, or if you want the first floor height to be different than the others. And yeah, when you've done that configuration, you can start generating. And then it takes all of the different information from the site. The GIS data, the context, it will collect from OpenStreetMap the directions, and it will perform a site analysis and try to populate buildings on that site. So it takes a few seconds, and we will soon get the information here. But so meanwhile we're waiting, we can have a look at, just to show you the principle, we can look at this one. So when you have your study ready, you will be presented with generated scenarios. And what we mean with a scenario is that we have a picture of the buildings on the site. We have some different KPIs. In this case, we have gross floor area and net internal area. We can, of course, modify this and say, okay, I'm not interested in the net internal area. I want to see number of units, and I want to see the amount of staircases maybe, or I want to see the facade area. And we're building up this. So this is the current version, but we're constantly adding parameters and evaluation criteria to the different cards and to the different scenarios. So when I have my scenarios up here, I can, of course, sort them. So maybe I want to sort this one on facade area. We can flip it around and say, okay, this one has the most. We can then say number of apartments. We can sort by gross floor area and so on. And we can also, of course, filter them out and say, okay, only show me the proposals with gross floor area over a certain range. Then we will see how this filter that I set up here, how this filter actually affects all of the other output parameters, such as number of apartments or gross internal area and net internal area. But there might be a case where I'm not happy with any of the proposals. Then I can, of course, go in and go back and modify my inputs and try to generate other options until I narrow down the scope and until I find a solution that meets my initial requirements and criteria. So yeah, if we, let's see, click in on one scenario, we can, of course, dig deeper into the model. And we will then see the scene as this. We will get information about the volume itself. We can interact with it and see how big the different units are. And we can play around with shadow settings. And this is already geolocated, so you don't need to think about adding longitude and latitude and that kind of things. And you can play around with different sun settings. You can step between your different proposals. And of course, you are able to extract additional data, such as the amount of units, certain distributions, areas like this, ratios. Yeah, I'm not going to go through all of the KPIs, but a lot of KPIs connected to each and every scenario. You are, of course, also able to download the proposal. You can measure and regenerate stuff, and you can customize your scene by toggling layers on and off, and yeah, play around with the different proposals, more or less. So yeah, that's pretty much it for this design template. And if we go back, we also I'll show you another design template. So here, for example, when we were working with modular construction, we have it in another resolution. So this is not the generic ones. This is based on a certain design logic and design script that is actually based on other kind of design criteria, shaft positions, and rules for how you can place an apartment next to another one. So we started here from another perspective, where it's from inside and out. And based on certain predefined units, we are able to build up a model based on another kind of design logic rules and another design logic regulations. But you can access the data here as well in a similar way, and also add additional data such as cost calculations. And in the end, we're also going to look more into like CO2 emissions and other kind of environmental analysis. But as a principle, we generate a base set of parameters and add additional layers on top of that when it comes to cost, and also to the profit side, where you can calculate the differences based on different cost models. So yeah, that's okay, let's see here. So that was a short live demo of what you could do. We also have a compare section where you can compare the different options. But yeah, I think we will not only talk about what we have and all our different features and capabilities. I think it's important as well and interesting to share with you our journey, and also like lessons learned from how we've been working with design generation and yeah, Rhino Compute later on as well. So yeah, we started as consultants working with parametric design. Both me and Eric, the other co-founder of Parametric Solutions, we had 2 different companies where we were working as consultants with parametric design, and we were working together with architectural companies, engineering firms, but also property developers. And just as an example, we worked a lot together with a Swedish development company, Bonava, which was former NCC Housing. And they had predefined houses for their single family housing units. So their template in Revit looked a bit like this. And then we could specify rules and constraints, not only for the models, but for the interfaces, for how these units could be connected to each other. And we also had to think outside the box and think about how these units how they could correlate to the streets. So we had to specify and put parameters and say, okay, how big is the backyard? How big is the front yard, the streets? Where is the access point to the streets and so on? So we codified a lot of different rules, and we could then start to iterate. And then we could iterate over this design scope and try out different subdivisions of the site, different populations of houses, and then we evaluated everything at the same time. And we ran this loop and we generated thousands of different options. And we were really proud of our customer value proposition. We said we can generate thousands of options in just a few seconds. But we quite soon realized that that was not really the case. And people didn't really, or the users, that was not what they were asking for. They were even more confused than if they did it themselves in a traditional way. So that did not really work, obviously. And so it is not about time, and it is not about quantity. So our biggest lessons learned is more like the initial approach that we started with was that we took the user specification and the site, and then it was more like a black box, and no users had a clue what was going on in the background. And then we presented the alternatives and said, okay, now you can pick one that you like. And that was even harder for our users to actually make decisions based on what they saw. So we had to rethink a lot. And I mean, if you just think about like design logic in general, it all comes down to hierarchy at one point. So when we start with bigger areas, take the site area with the houses that you just saw, for example, you could subdivide the site in a lot of different ways. Here we have 3 different subdivision types. The black line is represent how we split the site. For each subdivision, we can generate a lot of different footprints in 2D. So you see the first one here in the dashed box it has 3 different footprint configurations: closed quarters, some e-houses in the quarter structure, and then some point houses in 2D. And for this step, each and every proposal here has a lot of different variations when it comes to heights. So for this subdivision, we end up with an endless amount of different height configurations, especially when we don't have that many zoning restrictions and zoning regulations for larger sites, which means that the design scope is extremely big. And what we did in the beginning was that we presented this list and said, pick and choose. So that was not really what they were asking for. And we're now breaking it up into different steps. We focus a lot on the iteration between user and between these different stages. But we're also focusing a lot on like iterations and the possibility to go back and forth, because you get new insights and you get aware of new things along the process. So when you do inputs, when you put up your inputs, you get some results, then you should be able to modify your inputs. You should be able to analyze it. You should be able to generate more proposals, delete, discard, and reiterate. And we're now working on implementing Alexander is sick today, so he was the one who was going to talk about the AI stuff. But in general, we're also implementing like some genetic algorithms on each and every step to optimize not the whole workflow, but subparts, and in the end create better and more transparent solutions. But yeah, now we're gonna go even deeper and talk about the underlying structure and the Rhino compute stuff that we're doing. So I'm handing over to Henrik Frank now to just say a little bit about Rhino Compute.
Yeah, so it's if you're familiar with Grasshopper, Rhino Compute is a way you can run Rhino on a server. So you can use some sort of API endpoints to run your design scripts. And that's what we have built the entire platform around. So what's great about Rhino Compute, you can set up the server and then you can use your custom scripts. So we can easily plug in if there is some unique design logic our customers want. It's very easy to plug in a custom script there and make it available on the site. So it's a 3-part solution, as you can see. We have a UI that you have just seen in the demo, and the purpose of that is to show all the data and to create stuff. And then we have our backend service. That's like the centerpiece. The UI is connected to this. And then from this API, we can then send our data along to the compute server that then creates all the options. You can look at the next picture. And from the compute server, then we get back a bunch of data and some 3D models and stuff that then will be visualized in the UI again. So that's the basics of how the system is working. And yeah, so we plug in a bunch of different services. We work a lot with Mapbox, and Rhino Compute are like the main big things that we do. And yeah, that's it. Back to you, Sophia.
Yes, okay. So yes, and yes, Frank also mentioned, since we have Rhino Compute in the background, it's we built the rest of the platform in an as generic way as possible, and this actually opens up for adding a lot of different scripts and built up this design templates. Because working with different clients, we've realized it's not always one size fits all, and people have their own way of doing things, and it's important to like connect it to their specific workflows. So yeah, as shown before, as an example, we worked with a property development company in Vienna, where they had very specific ways of doing their units. So we had a standardized library of BIM models when it comes to different units, all the way from residential development to student housing to hotel rooms and to elderly living. And we knew a lot of data about the different units like this. And we could then, as you saw before, like connect and create the design logic from the inside and out perspective. Where, like, thanks to Rhino Compute, we can do the kind of customization and offer very, very, very specific ways of doing things. So yeah, that's it. And then we're also going to talk a little bit about what's upcoming and yeah, how we need to improve, and also to discuss with you all guys how you see this and what should be on our roadmap. So yeah, as mentioned, we've been working as consultants. We did our first MVP in 2022. We are now in beta mode, so we haven't done our release. It's an early beta, and we're looking for early people that would like to contribute and test out our platform to see how we can improve. And the plan is to do our first V1 release in the beginning of 2024. So before that, we are aiming to add unit optimization so that you can type in specific unit sizes and specific distributions to create and optimize within that. So if you think about the schema where we had the site division, the volumes, the 2D footprints, and then we're going to add another layer where you can actually lock certain volumes and do units distribution optimization inside. And then, of course, also validating all of these different options with simulations to validate the performance. So here we actually did this 2 years ago when we were in a pilot project together with an engineering firm. We implemented a pipeline with Rhino Compute in the background for actually running vertical sky components on the massing study in the platform. And it worked pretty well, but we're now going to add more simulation aspects and simulation criteria to all of this, so you actually can do multi-objective optimization for real. And the goal is to then contribute to like sustainable cities and communities. And we're also planning to add evaluation criteria for CO2 emissions and other kind of calculations that could be good from a sustainability perspective in early stages. And the third thing that we're looking into is, of course, the interoperability, where we have the API solution, as Frank mentioned in the beginning. We are already connecting it with Rhino Compute, but of course we're also going to connect it with other industry standard tools such as Rhino, Grasshopper, Revit, Dynamo, and also like IFC formats and ArchiCAD as well. And we're looking into Speckle solution a little bit for this, and we're also building a live link between both Revit and Rhino and the platform that we're offering. So before we actually like start doing too much of the implementation and the development, we're also super curious to actually hear from you and from the community. So for us, it's like very important to hear your feedback, to share ideas. I already see that we have 26 questions in the chat. I haven't checked it yet, but that would be great to have a discussion about that. And also, if you want to try it out, you are more than welcome to sign up for early access. It's free for the early beta. And I'll send this link in the chat if you want to sign up. We onboard 100 people at a time, so there might be a waiting queue. So we take it in chunks, but just so you know, if you are on the waiting list, you will be onboarded soon, but we take it 100 people at a time. So with that said, I'm curious to hear those 26 questions. So let's do some Q&A and open up for a discussion.
Yeah, thank you. It has been great, the presentation and the demo. There are really a lot of questions. I'm starting from the beginning just to don't lose them. And the first one is from Matthias that asks which countries are available at this point of development. Is Germany available? I think it's about the part when you presented the demo.
So all countries are available. But it depends a bit on how much open data you have in your country or in your city. But for the minimum level, where we only have the OpenStreetMap and when we have the Mapbox layers, that's available everywhere. But if you want to append data and override data with more information, then we have to look into certain cities and add additional information. So additional zoning information is not available for Germany, but we are constantly looking into where our users are based, and the more people we see from certain regions, the higher priority that city gets for implementing the open data datasets.
Okay, thank you. Next, we have quite a lot of questions from Guido. First is asking, how is this different from Forma?
Yeah, so the concept is quite similar, but what we are focusing on is much on doing these kind of custom solutions. We do single-family housing. We also do client-specific design scripts. But the concept in general is quite similar, actually.
Yeah. Okay. Next, he's asking, what do you think it will be adopted when multiple similar platforms have already failed? But I think it's different in this case.
You mean like, or sorry, I missed your first part in this.
Yeah, sorry. Yeah, Guido is asking, the second question is, why do you think Parametric Solutions is going to be adopted if other platforms, similar platforms have failed? But I think...
Yeah, I think it depends a lot on what the reasons why they have failed is. And I think maybe one kind of aspect could be the amount of different options. And we've done a lot of different interviews and interactions with our users, and we've seen the importance of the transparency and the control. So I think one of the biggest issues that or problems that we saw from the beginning was that we just generated a lot of different options, and that was not really what people were asking for. And I think a lot of different companies went into that issue when it comes to generative design, because they just produced a lot of different options, but people were not really asking for that. So I think that is one reason.
Yeah, I found that part of your presentation very interesting, because it's you're really taking the what the user needs, so, and you're adapting the product, and I think that's very interesting. His third question is, who is your market? What's your market?
That's actually interesting. We started to focus on property developers, but that was 2 years ago, and they were quite interested in like generating different options and to save time and to reduce lead times, and they wanted to do investigations in early stages before they even buy the land. So we focused a lot on property development in acquisition phase for land acquisition. But I mean, we still do that, but we've seen a lot of architects signing up for our platform. So we are now targeting more architects more and more, which means that we need to focus a little bit more on like interactions. We're implementing a nicer way of interacting with the proposals to sketch and create your own ideas, and rather see it as a digital assistant rather than just a tool that produces alternatives.
Thank you.
Developer and architects.
Okay. The last question here that is quite long is if it's the choice of Rhino Compute based on familiarity or accessibility, and also Grasshopper. I think he was asking later about what is based on Grasshopper too.
Yeah, at the beginning it was actually because of that we were familiar with Grasshopper, and also it was a really quick tool to do the prototyping in. And then we found out about Rhino Compute, and it suit our workflow and our architecture of the platform quite well. And then we also realized that when we onboard people to our team and when we hire new people, people know Grasshopper a lot, which means that we can also, when we onboard new people in our team, people can actually start producing scripts, and we can combine our consultancy service together with the platform in a quite fast way.
Nice.
Or do you have anything more to add to this question, Frank?
No, you answered all of it, I think.
Okay. Perfect.
Yeah. Okay, so well, this is not a question, but I think it was at the beginning of the demo also, and actually Abhishek, I think, is asking, well, it's not asking, it's just commenting that cost data could be great based on Ian data. I'm not sure what's the data.
Okay, I didn't really understand the question.
Yeah, sorry. It's from Abhishek Palit.
Let's see.
Abhishek.
I can see if I can check.
Yeah, no worries.
Oh, there was a lot of questions.
Yeah.
Okay, no, I cannot find it.
Okay, yeah, no worries. I can just copy it probably at the end if you prefer.
Yeah, that would be great.
I think it was at the beginning of the demo that you were showing some parameters, but not.
Okay. Now I see. Cost data would be great based
Yeah.
on ENR data. I'm not actually sure what ENR data is.
Yeah, me either.
But I mean, the one who wrote the question, if you could if you could specify a little bit more, that would be great.
It's a database for costs.
Okay. Yeah, of course, that we're not doing that at the moment. So at the moment, the user types in, I mean, we generate the base layer information, which is like square meters and units and that kind of things. But and then our users fill in as a top layer on top of that, they could fill in cost data. But of course, that would be interesting to, I mean, the calculations are in the background, but it would be interesting to take the coefficients and the data from a database to add that as well. So great idea. Great.
Yeah. Guido is asking another question that is if the models are, I can check it, are randomizing a parametric model through a multi-objective genetic algorithm.
Kind of, but not really. So we're looking, I mean, we started with just doing inputs and produce a lot of different options. Now we're looking more into optimization. We're looking into genetic algorithms and creating different parallel servers when it comes to Rhino compute to create a broader design scope and narrow down to solutions closer to what you were looking for. So we are now implementing targets, and we're implementing also what we call design drivers and objectives. So we're implementing some kind of genetic algorithms at the moment.
Okay, great. And Aman is asking if you can explain a bit more about how the context affects the design options generated.
Yeah, of course. So since it's based on Mapbox at the moment, we extract information from, I mean, if you have the site, we also know about what kind of buildings we have in the surroundings. We know where we have open structures. We know where we have more closed structures, if we have streets pointing towards the site. And then we pick those aspects and the context information and bring that into the algorithm. So we take the streets, for example, that are facing the site. That is an input for our subdivision when we divide the whole site into parcels. So it should align with streets in the surroundings. And also when it comes to, if we have a park, for example, or an open structure, we're taking that into consideration to not populate a very closed structure, like blocking the views and that kind of things. So we're taking into consideration different aspects at different times, but and then we're working on optimization for these kind of aspects as well.
Okay. Let me check if I not missed anything. Yeah. Ivana asked if it's possible to target only parts of one proposal for more iterations. So after you have the different scenarios, just to select one part and.
Yeah, okay, I think I see what you mean. Not at the moment, but we are looking into that. You should be able to have multiple parcels within, if you have a big area, you could have multiple parcels, and then you could click on a parcel and just regenerate stuff on that parcel. But that's we don't have that at the moment, but we've heard that feedback before. So we're working on a solution for that.
Okay, great. Okay, the next question is it possible to set the parameters of the apartments? For example, we design multi-story hotels in which the dimension of the rooms are known in advance.
Oh, sorry, could you say the last part there?
Yeah, it's the question from Bash Sheslav, and he said that they design multi-story hotels in which the dimension of the rooms are known in advance. So they want to set the the room
Oh
dimension.
yeah, you could yeah, of course you could do that. Yeah.
Yeah, I think this question was before you show this option.
Oh, right, all right. Yeah, so I mean, it depends a little bit, and we've realized that clients have different ways of approaching it. I mean, you could have flexible units within a certain target, saying that they could be X to Y, or you could have super fixed units that are predefined already. So it depends a little bit on the case, I would say.
Yeah, the next comment was quite similar, pretty similar. That says would be great if any prefab company can configure their prefab units, and I think
Yep.
it's
Yeah,
completely
we've
possible.
been thinking about that as well. Like, since we are able to match scripts with certain users, we will later on in our journey also open up for people to add their component libraries to the platform, which make it possible to set up specific customization rules for prefab companies, for example, and then be able to apply that to certain designs.
Okay. Okay. Nick Dodge asked for the Bonava project, how much efficiency was achieved with all the iteration of your scripts? If, for example, they were able to increase the number of units or reduce the amounts of roads needed?
Yeah, so first of all, we started to measure the time, of course, and we quite soon realized that, I mean, that is something that you can measure, because we said, okay, we can generate this amount of options in a certain amount of time. So that was one thing, that you could actually produce a lot of different options in just a few minutes. So of course that increased creativity if you look at it in that way. On the other hand, we quite soon realized that that was not really like the main value. But we also tried out on certain projects where we actually could fit in extra houses based on how we actually configure the site. But the biggest value and the biggest purpose is to actually see the consequences of the choices that you make, to inform and get the users and the project developers to understand that early on. So if you look at it on a holistic perspective, it's more like to give the user insights about it from a statistical point of view, rather than finding the exact solution. So it depends a little bit on how you see it.
Yeah. Okay. Okay, and Matthias Niemeyer asked, are you able to connect the buildings besides 90 degrees?
You mean if I can like snap it to corners and create like straight angles, or?
Yeah, I think so, because I think it's because most of the scenarios were like squares or rectangles or
Oh, yeah. You can have
Is
flexible corners that could be any angle that you want, or you can have 90-degree angles. Yeah.
okay. Okay, and Thomas Rockon asked, how or where do you personally see the future of architects with your and similar services?
Yeah, for us, I think like when we have done all of these different tests, it is very clear that the architect will be the one having control and making the decisions about what is good architecture, what is a good proposal, what is not a good proposal. And so I think this is more like a digital assistant for producing concepts fast, but we see it as that the architect should have full control over what to choose, what to generate, what to continue with, what to discard. So the architect will be the one controlling this.
Yeah. Okay, and Agnes asked, how much experience you have in your team from working with urban design more traditionally, or how much user feedback you have received from users who work professional with urban design?
We've mainly actually worked on the neighborhood scale, and we're now looking for people that works with urban design to actually do some pilots and try it out on an urban scale to make it better on that scale. But we're mainly focused on the neighborhood size at the moment. So that will be interesting to continue the discussion.
Yeah. Okay, and Rosai ask, do your algorithms run on computer, or sorry, do your algorithms run on a compute server, or you do it on a separate server and making calls to compute?
That's a question for you, Frank.
Yeah.
Yeah, we have a server for running a compute, and then we have separate services for other things that we connect.
Okay, thank you. Um, yeah, this is a quite complex question from Joe Grant. He asked, for social cohesion and sustainability, what theories do you draw upon, and how do you script logical rules and parameters to configure a design?
Okay, let's see. Could you? Sorry.
Yeah, I can copy.
But
No worries. I think it's quite complex to follow the chat.
yeah, I'm trying to navigate and
And
see
this
where
is
that question is. For social, okay. We're actually not we're not including that at the moment. That would be super interesting to include and see how we can include that kind of evaluation, but also as a starting point for the design. But at the moment, it's very much based on geometrical inputs. So as it is right now, the user they have to understand the theories for that and like kind of translate that into geometrical inputs. So it's like a bridge between that and the inputs for generating options. So we haven't included that so far.
yeah, it's more complex to add a value to that kind of parameters.
Yeah, exactly. I think as it is right now, I think it makes sense for the user to actually decide more on a concrete level when it comes to geometry.
Yeah, I agree.
Mm.
Okay, and next one is, which metrics do you optimize? For instance, maximize density, sunlight, etc., and which are randomly generated.
Yeah, so at the moment we're working with targets, and we of course started with the FAR ratio. So you optimize for density and you optimize for square meters. And then the randomness is like the position and the alignment and also the subdivision. So we create a lot of different subdivisions, and then we optimize for certain criteria for the subdivision. If you like say that you want quarter structure, for example, we optimize the site division for creating as good parcels for quarters as possible. So it depends on which kind of level you're looking into, or that you look at when it comes to the optimization. But in the end, we're at the moment optimizing for square meters, and we're now looking into more quality aspects as well.
Okay, thank you. I think one of the last ones is, do you think the market has changed in terms of user interest since the release of generative AI platforms?
Yes.
Yeah.
Yeah.
Okay. I think the rest are comments. Just my comment. Saying thank you for the answers. Another question from Kay Regan. Will you provide users with ability to build their own typology prototype libraries for testing?
Later on, yes. At the moment, we try to keep it as tight and as small as possible to like narrow down the processes and the KPIs and everything. But in the end, we're going to open up for customers and people to build their own typology libraries and maybe even create their own scripts in our generative design engine.
Okay. There is another one from Matthias. Are you able to ask the script some initial questions, like give me the max ground floor area in combination of required offset to different existing buildings or in between the new buildings?
Kind of, but we're not really asking the script for that. The script is like just the model, and then we're looking at the evaluation criteria like around the script. So then we adjust the inputs based on what you're looking for in your output, and that's how we try to do the optimization principle. So kind of.
Okay. Yeah, okay. I'm checking the next comments. Yeah, Alexander saying that the different layers of the Vienna documents were amazing, and that every city should present their planning documents. If you're going to have access to the webinar, yes, I'm going to upload it to YouTube tomorrow, probably in the morning. So you can check it in our YouTube channel. Yeah, rest are just thank you for the presentation, and it has been really great. I think it was more quite clear how it works, and also it was very interesting to see all the process of how you created this platform.
Okay, perfect. Yeah, and I mean, thank you to all of you for listening and for participating and for all good questions.
Yeah, a lot of them. Thank you all for joining the webinar, and thank you, Sophia and Henrik, for presenting it. It has been
Yeah, thank you
really
very much.
amazing.
Okay, thank you. Bye.
Thank you. Bye bye. Have a nice afternoon.
Bye.
Bye. Thank you.